In January 2010, inspectors from the International Atomic Energy Agency noticed something strange at the Natanz uranium enrichment plant in Iran. The centrifuges' massive supersonic spinning tubes used to separate nuclear isotopes were failing at an impossible rate. They weren't just breaking, they were destroying themselves. The Iranian engineers were baffled. They replaced the broken machines, checked the power lines, and inspected the hardware. Everything looked normal. The control room screens showed all systems operating perfectly. Green lights, stable speeds, no errors. But down on the factory floor, the centrifuges were spinning out of control, vibrating until they shattered into shrapnel. They didn't know it yet, but they were the victims of the world's first digital weapon. This is the story of Stuxnet, a computer worm so advanced, so precise, and so destructive that it changed the history of warfare forever. Stuxnet was unlike any virus seen before. Most malware is written by criminals to steal credit card numbers or by teenagers to show off. Stuxnet was written by a superpower. It was designed with a single, terrifying purpose to cross the air gap. The Natanz nuclear facility was not connected to the internet. You couldn't hack it remotely. To get inside, the attackers needed a physical bridge. It is believed that Stuxnet was carried into the facility on a simple USB thumb drive, likely by an unknowing engineer or a double agent. Once plugged in, the worm woke up. It utilized not one, but 4 zero-day exploits, secret vulnerabilities in Windows that no one, not even Microsoft, knew about. On the black market, a single zero-day can cost hundreds of thousands of dollars. Stuxnet used 4 of them at once. It was a masterpiece of coding that likely cost millions to develop. Once inside the network, Stuxnet didn't attack immediately. It hunted. It silently scanned every computer it infected, looking for a specific configuration. Siemens Step 7 software connected to a specific model of frequency converter drive. If it didn't find this exact target, it did nothing. It just hid. But when it finally found the target, the computers controlling the nuclear centrifuges, it initiated its payload. It began to secretly alter the speed of the spinning rotors. It would speed them up to 1,410 Hz, just fast enough to cause the metal to crack and warp, and then slow them down to 2 Hz to disrupt the enrichment process. And here's the most terrifying part. While it was destroying the machines, it was lying to the humans. Stuxnet performed a man-in-the-middle attack on the control room screens. It recorded a loop of normal sensor data, showing steady, safe speeds, and played that recording back to the operators. The engineers watched their screens, seeing everything green and stable, while behind the glass, their nuclear program was tearing itself apart. By the time Stuxnet was discovered, it had destroyed nearly 1,000 centrifuges, setting the Iranian nuclear program back by years. No country has ever officially claimed responsibility, though it is widely accepted to be a joint operation between the United States and Israel, known as Operation Olympic Games. Stuxnet proved that code is no longer just lines on a screen. It is a physical weapon. It can destroy machinery, explode pipelines, and darken cities. The genie is out of the bottle, and in the silent war of infrastructure, Stuxnet was just the opening shot. Subscribe to the Silicon Archives, the compilation